Here we're going to look at topic 74, example 3, solve a quadratic equation by completing the square. How can you solve 0 equals x squared minus 2x plus 3 by completing the square? So let's take our equation, and we recognize that this is not a perfect square trinomial because there are not factors of 3 that add up to -2 that are the same, right? Doesn't work. So what we're going to do is we're going to subtract 3 from each side, and we'll have -3 is equal to x squared minus 2x. And I'm going to leave a little bit of space there. And what I want to do here is, this is ax squared plus bx plus c. I want to use b over 2 squared. And I'm going to use that expression to complete my square. So b in this problem is the value of -2, right? So whether you want to look at it from here or the original, anyway works. So for b, we plug in -2, and we would square that. So -2 divided by 2 would be -1, and -1 squared is 1. So this value of 1, let's put that in orange, is going to get added to both sides of our equation. So +1 plus 1. So the left side, -3 plus 1 becomes -2. And the right side, if we were to factor this, and I'll write the full process out, but you should get the idea from here, is we're going to have x minus 1 times x minus 1, and that's the factor sum method. So if you actually wanted to create the chart over here, we need factors of 1 that have a sum of -2. Well, 1 and 1 get 1 when multiplied, but they don't add up to a -2, they add up to a +2. However, -1 times -1 is +1 when multiplied, and -2 when added when we find the sum. So we would rewrite this in the form, if you go back to example 2, this x plus p squared equals q form. So we have -2 equals x minus 1 squared. You can then take the square of each side, and remember, if we have negatives, we have the value of I. So we're going to take out a positive and negative I here, leave the 2 inside, and that would be equal to x minus 1. We do have 2 solutions, so we want to figure out what those are. So we can do x minus 1 equals I radical 2, and x minus 1 equals -I radical 2. Create a little space here. So what we're doing is we're taking this piece here and we're creating 2 equations. So it's x minus 1 is going to equal the positive version of I radical 2, and x minus 1 equals the negative version of -I radical 2. So we would add 1 to each side. You can't combine those because they're unlike terms, so we're just going to write them next to each other. So this would be x is equal to 1 plus I radical 2. And here, again, add 1, unlike terms, so x is equal to 1 minus I radical 2. And those are our solutions. You won't always have the imaginary term or the complex number I, but in this case we do. So we do want to be careful with that. We want to be aware of that. But the idea is really focused on this b over 2 squared part. That'll be used to complete the square. And make sure you start to recognize this step here. Right, how to go from a perfect square trinomial and then writing it as the binomial squared. Try 3a and 3b and see how you do.